Okay, so this topic is molar mass of CaCl2, calcium chloride, chemical formula CaCl2. So what we need to look at therefore is, well, first of all we need to look at this idea of, you know, a dozen. A dozen is equal to 12, a gross is equal to 144. So a mole, is another quantity. A mole is just the number of atoms, the hash, or the number of atoms. And that number turns out to be Avogadro's number, which is 6.022 by 10 to the 23. Atoms are molecules. Okay, so we make the comparison of a bank. Of a bank cashier, and if you know the mass of one coin and you've got the mass of the bag, then that means that you can actually work out then how many coins are in the bag, or in our example it would be how many atoms are present. Okay, so we have to follow the logic then. Using Avogadro's logic, if we know that an atom of magnesium is 24 atomic mass units, is twice as heavy as an atom of carbon, which is 12 atomic mass units, it follows that 100 atoms of magnesium will be twice as heavy as 100 atoms of carbon. And if we extend that idea then, if we have a piece of magnesium that is twice the weight of a piece of carbon, the two amounts must have equal numbers of atoms, and that just follows from logic. And this is when the whole idea gets very interesting then, because at this point then we're saying, well, if we've a piece of one material and then another piece of another material, we can find out interesting things like how many atoms are present and such like. Okay, so here's where we talk about the mathematics of it then, and it's very straightforward. Look at it. Carbon-12 atom has 12 atomic mass units, straight from the periodic table. A magnesium-24 atom has a mass of 24 atomic mass units, again straight from the periodic table. Now, when we talk about a mole of either of these, all you simply do is you convert the atomic mass units to grams. So 1 mole of carbon-12 with 12 AMU is 1 mole of that is 12 grams. And similarly for magnesium, 24 AMUs, atomic mass units, is equal to 24 grams. And then just simply over here, we've kind of scaled things up. Okay, we've said that 1 mole of carbon is equal to 12 grams, 1 mole that is. Well, it follows then if you have 2 moles, it means that you have, if you like, 2 heaps from that. Remember interestingly that the word mole comes from the Latin word moles, meaning a heap or a pile. So, it draws attention to the particle nature of matter being a heap or a pile of particles containing the Avogadro constant number of particles. So it's interesting from that point of view. So, going back to this again, if you like, 1 heap equals 12 grams, whereas if you double that heap, now it's specific because we're talking about Avogadro's number, 1 mole is 12 grams, 2 moles is equal to 24 grams, and simply 0.5 moles then is a half, which would be 6 grams of the original 12 grams. So it's as simple as that. And molarity doesn't have to be restricted to just atoms. Like for instance, in the question we're doing, and in this example here that I'm just highlighting, the water molecule is a collection of atoms that makes up a molecule. So it doesn't necessarily have to be atoms, it can be molecules as well. It weighs 18 atomic mass units, and for this molecule we just do the same thing. 1 mole of H2O therefore weighs 18.0, not AMUs but grams, and very straightforward. And again, for the molecule, how that's working out then is for hydrogen, that's 1 atomic mass unit. For the other hydrogen, because it's H2, it's 1 atomic mass unit. And then for oxygen, it's very straightforward, 16 atomic mass units straight off the periodic table. Okay, so to our example then, we're looking at the molar mass of CaCl2, calcium chloride. So you've got your chemical formula is CaCl2. Simply you look at the molecular mass of calcium straight from the periodic table, 40.078 AMU. Chlorine, you've got it there, and therefore we have the formula weight of CaCl2. 2 chlorines, as you can see, the calcium at 40.078 plus 2 by 35.453, which gives a total quantity of 110.984 atomic mass units. And then really straightforward, just like the example above, we do a direct conversion. We have 110.984 atomic mass units. Therefore, 1 mole of CaCl2 would have a mass of 110.984. But now we convert it to grams. That's what we do directly. We convert the atomic mass units to grams for 1 mole. And the next thing we've got to do is we have to bump it up to 1.5 moles. This is only 1 mole weighs this amount. Obviously 1.5 is going to be somewhat heavier than that. So we've just got to do the maths on that. And there we have it below. We've got 1.5 in the first bracket, we've got 110.984 in the second bracket. So do a multiply, plug and chug, and we get an answer of 166.476 grams, which is bigger than this answer as we expected and predicted from above. So the answer is 166.476 grams. The final thing we've got to have a look at then is the unit analysis, and this is really important because we have moles in the first bracket, in the second we've got grams over moles, and when we do our check of that we should end up with an answer in grams. And obviously what's going to happen then, and this is perfect and as expected, the mole above strikes the mole below underneath, and we're left with our unit, which is grams, which is the mass that we expected from our answer, 166.476 grams. The unit is correct and our unit analysis checks out. So we've just worked out 1.5 moles of the substance, and now if we change the ratio and we change it to 0.5 moles of CaCl2, well, it's simply going to be 0.5 molar by 110.984 grams per mole. Okay, so we've changed it to 0.5 moles, and as we expect, because it's not 1 mole anymore, we expect the number to reduce, and you see down here in the answer that it does. And also we see that our unit checks out again because the mass is listed in grams as we require, which means that the molar quantities above and below have cancelled. And there you see it.